Hello everyone, good afternoon to all. My name is Rabindra Sharma. I am a physics teacher. I have done BE in Electronics and Communication Engineering and MBA in Operations Management. I am fond of teaching and especially physics. I am taking online classes of 10th class physics for more than 3 years. Today's topic is Pulley system under the heading machine. And what are we going to cover here today? We will be covering types of pulley, and under this heading we will study about single fixed pulley, single movable pulley, double pulleys, even which is called combination of pulleys also, which includes single movable pulley with a fixed pulley. We can see here the figure is also available here. In case of single fixed pulley, even we have already gone through it in details, but we'll go here in brief. In case of single fixed pulley, you can see in this figure, one end is connected to the load, which is to be lifted or shifted from one place to other place, and the other end is used for applying the efforts. In this case, the effort is applied in downward direction and load is going up, means in upward direction. In case of single movable pulley, we can see here in this figure, one end is directly attached with the hook, which is fixed with the rigid support. The other end is free, where the effort is applied, and effort is applied here in upward direction. This is the difference. What we have seen here, in case of single fixed pulley, the effort is applied in downward direction. See here. And in case of this one, movable pulley, the effort is applied in upward direction. But here the load is directly connected with the pulley. See, this is the load which is directly connected with this pulley. Right. You can see one more figure here, which is the combination of fixed pulley and the movable pulley. See here. And what is the advantage here? See, with the use of one additional pulley, that is fixed pulley, along with the movable pulley, what we have done here, we can change the direction of the applying effort, which is very much comfortable for using this machine. And this is also desired. We want to apply this force in downward direction, which is always comfortable. Correct? See, this is movable pulley, this is movable pulley, and this is the fixed pulley. Earlier, in the middle of this figure, we can see here the force was applied in upward direction. With the help of this fixed pulley, now the effort is applied in downward direction. Right. Okay. As already studied here in other classes, in case of fixed pulley, the mechanical advantage is 1. But in case of movable pulley, the mechanical advantage is 2. Even the velocity ratio is also 2 in case of movable pulley. But what we have done here in third figure with the help of fixed pulley, we have changed the direction, but there is no any change of value of mechanical advantage and velocity ratio in case of this combined figure. You see, combination of both the pulleys, that is fixed pulley and movable pulley, right? Okay, what we can do here, let us calculate the mechanical advantages and velocity ratio as well as the efficiency of the movable pulley which is used along with the fixed pulley. See, what is mechanical advantages? Okay, mechanical advantages in short MA. This is the ratio of load and effort. Okay, L stands for load. Okay, and E stands for effort. Right. This is load. L means load, and this is effort. Okay, fine. See, in this figure, this load is directly connected with this movable pulley. Okay, and what is the beauty of this machine? Only one string is being used here. One string is running from movable pulley to fixed pulley here. Okay, as we know, if single string is used, there is no any change in the tension in the string. Everywhere the tension in the string will be the same. That's why, see here, this is the direction of the tension. What we have written here, T. Same tension is there in this string here also, but in upward direction. Here also, when this effort is applied, I mean to say force is applied, there will be equal and opposite direction of this tension. So we can say here this effort is equal to T. Fine. Okay. So as per the definition, what we have written here, MA, that is mechanical advantage equal to load by effort, L by E. If we can find out the value of load, that is L, and efforts, then very well we can write down the ratio of both to find out the value of MA of this combination of systems, that is one movable pulley and other fixed pulley, right? See here, as per this figure, in case of this movable pulley, L, this load is equivalent to both summation of this T, first T and second T, right? So we can write here, you can write here from the figure, L is equivalent to T plus T, that is 2T. We can write here. Okay, fine. Let us suppose this is equation number 1. Here, where this effort is applied, here the effort is equal and opposite of this tension T. We have already here written is equal to T. Okay, so we can write here and from this figure we can write here E is equal to T. Okay, this is equation number 2. We can write here. Now, from this equation number 1, the value of L is available. in terms of T, and from equation number 2, the value of E is directly, where the directly equivalent to T, it is available. Now, as per this formula, where we have already written MA. MA means mechanical advantage equal to L by E, right? In place of L, what we can write here from equation number 1, we can write here 2T, and the value of E, we can write T. This T will cancel out with this T, so this will be equal to 2. So we can write here the mechanical advantage of this combination of pulleys, that is one movable pulley and other fixed pulley, will be equal to 2. Means what is the conclusion? It is concluded here that half effort is required to lift or shift the double load in quantity. For example, let us suppose we have to lift 100 kgf, okay, of load. Means here L is 100 kgf. It means efforts applied will be only 50 kgf. Right. So, in case of Newton, if you want to write down here, let us suppose, for example, we know, as we know, 1 kgf is equivalent to how much? 9.8 Newton, or it is equivalent to 10 Newton. We can write here 10 Newton. If you want to convert this unit from kgf to Newton, what we have to do? We have to just multiply with 10. So that result will be coming out in terms of Newton. We must know how to convert the unit from kgf to Newton, right? So what we have calculated here, the mechanical advantage of this combination of pulley is 2. Okay, fine. Next point, how to calculate the value of voltage ratio, that is voltage ratio. In short, we write here VR. Okay, this VR is equivalent to distance covered by the effort, and this is the ratio. Velocity ratio is the distance covered by the effort and distance covered by the load. We can write here distance covered by effort. Okay, in short, we can write here dE. Let us suppose the distance covered by this effort in downward direction is dE, right? And the distance covered by this load, when this effort is applied, it means it has to go upward direction, right? So this distance is, let us suppose it is dl, right? So we can write here distance covered by load. So we can write here this is d dE, and this one is dl. in short, right? Okay, it means velocity ratio VR equal to dE by dl. Let us find out the value of dE and dl. Okay, this d let d is equal to d. You see the symbol of d, distance. It means when this effort is being applied in downward direction by d, how much distance will be covered by this load in upward direction. See, the segment of this string, okay, is being distributed both sides, this end, first end, and second end. When the force is applied in downward direction here, this rope, or we can say string, is going in downward direction. The same length, whatever this length is being separated from this pulley, the same length is distributed here, both sides, on movable pulley. So here what we have assumed, the distance covered by this effort is d. It means this distance, this one means this load will go up just half of it. Half of it means d by 2, right? So this is the relation between the two. When efforts is going down by distance d, then the load will go just half of it, that is d by 2, right? So we can write here d de, what is the value of d, what we have assumed here, d divided by, and what is the value of dl, this is the value of dl, d by 2. We can write here d by 2. So we can write here d by 2. Okay, so d multiplied, it will be just opposite 2 by d. D will get cancelled with d, it will be equal to 2. It means velocity ratio in this combination of one movable pulley and fixed pulley will be also equal to 2. It means what? What we have calculated here. Let us suppose, for example, the efforts is being moved by 4 meter of length, means DE is equivalent to 4 meter of distance in downward direction. Then by what value the load will go up? So we can simply say here the DL means the load will go up by 2 meter only. Okay, this is the relation between the two, means it will be just double, so it will be just half of it. Okay, so we have calculated the value of VR and the value of mechanical advantage also in this case combination. Okay, one more thing we can calculate here, that is efficiency. Okay, efficiency that is denoted by eta. Eta is equal to, that is mechanical advantage by velocity ratio VR, that will be 2 by 2 is equal to 1. It means 100%. It means the efficiency, or you can say the performance of this machine where the combination of movable pulley and one fixed pulley used is 100%. Okay, this is the advantage. So generally this type of combination or this type of simple machine is being used in zip line. Okay, fine. So let us close here. I'm sure you might have understood, and you'll get advantage of it also. Okay, thank you all.